Good day. I will be presenting concepts, principles, and practices of nuclear power plant and ocean thermal energy conversion system. So I am Mr. Brand Ofoa from BSME 3A. Nuclear power plant. A nuclear power plant is a facility that generates electricity through nuclear reactions. The concept involves harnessing the energy released from nuclear fission, which occurs when the nucleus of an atom such as uranium or plutonium is split into smaller fragments. This process releases a significant amount of energy in the form of heat. So, the principles of nuclear power plant. First, nuclear fission. Nuclear power plants operate on the principle of nuclear fission, where the nucleus of a heavy atom such as uranium-235 or plutonium-239 is split into smaller fragments. This process releases a tremendous amount of energy. Number 2. Controlled chain reaction. The nuclear fission process is carefully controlled in nuclear power plant. Neutrons released during the fission of one atom are absorbed by nearby atoms, causing them to split as well, creating a chain reaction. By controlling the rate and intensity of this chain reaction through the use of control rods, the plant can maintain a steady supply of energy. Number 3. Heat generation. Nuclear fission generates a significant amount of heat. In a nuclear power plant, this heat transferred to a coolant such as water or liquid metals, circulating through the reactor core. The heat coolant then passes through a heat exchanger to transfer the thermal energy to a secondary cooling system. Then the steam generation. The thermal energy from the coolant is used to produce steam by heating water in a separate system. The high-pressure steam then drives a turbine which is connected to a generator to produce electricity. Safety system. Nuclear power plants have multiple safety systems in place to ensure safe operation and prevent accidents. These include control rods to regulate the nuclear reaction, containment structures to prevent the release of radioactive materials, and backup cooling system for emergency shutdowns. This is a sample picture of operating principle in nuclear power plant. Ocean thermal energy conversion system. Ocean thermal energy conversion system technologies use the temperature between warm seawater at the surface of the ocean and the cold seawater at between 800 to 1000 meter depth to produce electricity. The warm seawater is used to produce a vapor that acts as a working fluid to drive turbines. The cold water is used to condense the vapor and ensure the vapor pressure differences drives the turbine. OTEC system can be operated using two main approaches. First, the open cycle system. Warmer surface water is introduced through a valve in a low-pressure compartment and flush evaporated. The vapor drives a generator and is condensed by the cold seawater pumped up from below. The condensed water can be collected and, because it is fresh water, used for various purposes. Additionally, the cold seawater pumped up from below after being used to facilitate condensation can be introduced in an air conditioning system. As such, system can produce power, fresh water, and air conditioning. Furthermore, the cold water can be potentially be used for agricultural purposes, as the seawater from the deep region close to the sea contains various nutrients like nitrogen and phosphates. Closed cycle system. Surface water, the higher temperature, is used to provide heat to a working fluid with a low boiling temperature, hence providing high vapor pressure. Most commonly, ammonia is used as a working fluid, although propylene and refrigerants have also been studied. The vapor drives a generator that produces electricity. The working fluid vapor is condensed by the cold water from the deep ocean and pumped back in a closed system. The major difference between open and closed system is much smaller duct size and smaller turbines diameter for a closed cycle, as well as the surface area required by the heat exchangers for the effective heat transfer. Closed conversion cycles offer a more efficient use of the thermal resource, as Lewis et al. 2011. Principles are: number 1, temperature gradient. The principle behind OTEC system is the utilization of the temperature difference between warm surface water and cold deep water in oceans. This gradient exists due to the absorption of solar energy at the water surface and cooling effect of the deep ocean water. Number 2, heat transfer. OTEC system use heat exchanger to transfer thermal energy from warm surface water to a working fluid. Number 3, condensation. After driving the turbine, the vapor from closed system cycle or the steam from the open cycle system is condensed using cold deep water. The condensation releases the heat energy, allowing the working fluid or steam to return its liquid state for reuse. Number 4, environmental benefits. OTEC system have the potential for additional benefits beyond electricity generation. These are the references.
Thank you for listening.